Alrighty, for the practice here, let's see if we can do this with no editing required. That would be superb. Number one, we're going to find the line that starts at -2, 5 and goes to 4, 3. Now, they didn't tell us anything about the timing of this, so I'm just going to assume that it's going to be 1 second to move from A to B. And I'm going to just be using our new best friend equations over here in order to solve this. And then I do need some sort of time interval, but I'm just going to not write that over there for now. So here I need to figure out what is the change in the x values, always doing the ending point minus the beginning point. So I'm going to do 4 minus -2, so that is 6. For y, 3 minus 5, that's going to be -2. And because they didn't tell me otherwise, I'm going to assume that the change in time is 1. Now I can just plug it right into those equations over there. So I'll have x equals the change in the x values, which is 6 over 1 times t plus the starting x value, -2. If I was smart, I would have just written that as 6t minus 2. Y, its rate of change is -2t, and then plus its starting value is 5. And because it is a line and lines go on forever, I'm going to put it from -infinity to infinity. Ta-da! Done. All right, 2, we're going line segment, fun, -5, B is 3, 0, and it's moving from left to right. All right, for 2, what we need to figure out first is what this left to right is telling us, whether it means that we're going from A to B or from B to A. So easiest thing to do is just to super quickly sketch a rough graph of it. So this is 1, -5, so here's where A is, and then B is at 3, 0, which is right here. So if I'm moving from left to right, I am moving from A to B. So that tells me that I'm starting here and that I'm ending here. So using our best friend equations over there, we got the change in the x values is going to be 3 minus 1, so that's 2. Change in the y values is going to be 0 minus a -5, which is +5. They did not tell us what t is, so we're just going to assume it's 1 because that makes our lives easy. Now I can just plug this in to the equations up there. So I'll have 2t plus 1, the starting value for x, and 5t minus 5, starting value for y. And because it's a line segment, and I assumed that this was happening, whenever we do that, this equation, these guys right here, this is assuming always that the start happens at t equals 0. So that's why I know that it's starting at t equals 0, and I'm just going to 1 because I assumed delta t was 1. And that's my equations. Done. I gotta find a way to get this up on my table. I'm like tired of sitting on the ground. 3, line segment again. A, 4, -2, B, -4, 1, and we're going from right to left. All right, so if we're going from right to left, same thing. I gotta just do a quick little graph of this. So I'm gonna have 4, -2, and then -4, +1. So here's A and here's B. So I'm moving from right to left. So A is still my start and B is still where I'm going to end. So find the change in the x values. So -4 minus 4 is -8. There's an x right there, kind of forgot that. Change in y is going to be 1 minus a -2, so that is +3. They did not tell me anything about t again, so I'm just going to let it be 1 because that's the easiest number to work with. Plug it into the equations. -8t plus 4. Y is going to equal 3t minus 2. And it's a line segment. This equation is built off of t being 0 at the starting point, delta t we assumed to be 1, so we will go from 0 to 1. Done. Now, if we had, let's say, let delta t equal 4, then we would have had to divide each of these slopes by 4, and then this would be a 4, and this would work as well. So there's like an infinite number of solutions here. How many questions do you think there are for this? Whew. Line segment again. We're going from -4 to 2, and 3 seconds later we're ending at that, okay? So that's big. Delta t equals 3 this time around. Let's find delta x. That's just going to be 3 minus -5, so that's 8. Delta y is going to be 4 minus 2, which is 2. Plug it into our equations over here. We do have to be careful now. We have 8. We need to divide by 3 because our delta t is now 3, not 1. Plus the starting x value. Y is going to be 2 divided by 3. Okay, so the change in y over the change in time. Plus its value. And then we are starting at 0 because those formulas are always starting at 0. And we are ending at 3 because delta t is 3 and it's a line segment. Ta-da! Done. Oh, goodness gracious me. All right, someone lives 4 miles apart from each other on a straight road. At 6 p.m., their moms agree to let them both leave and ride their bikes towards one another. One of them can pedal 12 miles per hour, and the other one can pedal at 8 miles per hour. All right, so I'm going to use my answer key names. I know those are different than the names that are in your packets. So I have Joe can go at 8 miles per hour. So Joe's delta x, because we're doing horizontal distance, although we could do vertical, but I'm basically saying, like, here's one of their houses, and here's the other one, and these guys are 4 miles apart from each other. So I'm just going to allow the horizontal distance between the two houses to be 4. So let's say that Joe lives in this house. He's going to pedal in a positive x direction towards Alex, who lives in that house. So this is going to be 8t, and let's just assume that this is at 0, 0, because we weren't told otherwise. Now, for the y values, because we're only modeling horizontal distance, we don't care about vertical, this can be anything that you want it to be. So I'm just going to leave it as nothing for now. Now, Alex's equation is a little bit different. So Alex is going towards Joe, but that's at a negative x value. So Alex's rate of change is actually negative 12t because Alex is traveling backwards in the x direction, and he starts 4 miles away from Joe's 0, 0. So we need to take that into account by adding that 4 miles in. Same thing for the y values, they could be anything. So I want to know when and where will they meet each other. So let's just set the x values equal to each other. So 8t equals negative 12t plus 4. I will add this to the other side. I'll get 20t equals 4. So t is going to equal 4 over 20, which is 1/5. So that's at 0.2 hours, because these 8 and 12 were in miles per hour. If we wanted to, we could convert this and figure out that that is 12 minutes. Okay? Now, if we want to know exactly how far apart they are, we just have to take this and plug it into one of the x equations. It does not matter which one. I do need to plug in 0.2, though, not the 12, because my equation's written in hours. So if I do this, I'm going to get 1.6 miles. And I actually plugged this one into Joe's equation. And if I plugged it into Alex's equation, I would get the exact same thing. It's just a little bit harder to plug it into this one because we have to, add this 4 back in. But we would get 1.6 as well. And if we really wanted to, we could do all sorts of things. We could say that they met right here, 1.6 miles from Joe's house, which is 2.4 miles from Alex's house. So Alex went much further, but that's because Alex was going 12 miles per hour compared to Joe, who was only going 8. Super fun. Oh, you're going to hate this one. You missed bearings, right? Like those are your best friends. Whew. All right, so 4-6, we have a plane A that's chilling over here. It's got a bearing of north 40 east, so that's going to be 50 right there, and it's traveling at 600 miles per hour. And at the same time, second plane, which is 1,000 miles to the east, okay, that's where B's chilling. It's going north 52, okay, so that's going to be 52 minus 90 will give me the 38 right there. This guy's traveling at 550, okay? So what we want to figure out here is a set of parametric equations that model these two planes' motions, okay? So rather than using the delta x over delta t and the delta y over delta t, what I'm going to use is their vector equivalent. So when we would write these in vector brackets, we would say 600 cosine 50, 600 sine 50, and this guy would have been, let's see, 550 cosine and then something, right? Because we need to use a direction angle, and then 550 sine something. So those are actually the rates of change. So for plane A, I don't know why I keep writing that instead of the x values. I can't. My goodness gracious me. Oh boy. There we go. There we go. All right. So I'm going to assume that this guy is at 0, 0, because that makes my life easy. So this plane is going to be 600 cosine 50 degrees, and then just multiply that by t. So this captures the rate of change, 600, and the direction, and I just multiply it by t, and that will allow this to happen over time. The y equation for plane A is going to be really similar. 600 sine 50 times t. And we're basically done with that. Now for B, things get a little bit trickier. So first thing is, I'm going to take into account this 1,000 and say that B has to start 1,000 away in just the x direction, because it's just directly east, which is just an x value. And now, rather than figuring out what this angle is right here and doing, 180 minus 38, which you could do, what I'm going to do is actually just subtract the 550 cosine 38 and then times t. And what this does is this negative makes us point backwards in the x direction, which is what we need, right? Plane B needs to fly in the negative x direction. And it just so happens that whatever this value is, whatever this number is, if I plugged it in here, it has a reference angle of 38, and it would have made cosine negative. So rather than me putting in the actual true direction angle, I'm just manually putting a negative sign in there to make sure it goes in the right direction. Now, y for b, I don't need to do anything with 1,000. That was just in the x direction. And I can do 550 sine, and the angle I put in here, let's think about this again. I need it to be going up, so I can use 38 and just leave it as positive, because whatever this guy is, its reference angle is 38, and sine in quadrants 1 and 2 would be the same. So I don't need to play around with the angle. And I know that you still don't really like that, but just take your calculator out, figure out what this number is. 180 minus 38, do cosine of 38 with a negative sign in front of it, and do cosine of whatever that number is. You'll see that they're the same thing, sine of 38 and sine of that number. You get the exact same thing. So we're basically using a reference angle and manually putting in whether it should be positive or negative. Now, the second half of this question asks, is there danger of collision? So we're going to do the same thing that we did in the question with Marissa and Bea, which is we want to know whether or not these things are going to hit each other. So I'm going to start off by setting the x values equal to each other. And I want to know what time that happens. Okay, so I just do 600 cosine 50 times t equals 1,000 minus 550 cosine 38 t. I'm going to add this to the other side, and I'm going to factor t out all at the same time. So I'm going to have 600 cosine 50 plus the 550 cosine 38, and then I'm factoring out a t because they both have a t in it, and that will equal the 1,000. And then I'm just going to divide this whole hot mess. Oh, there. I'm going to very carefully enter this all into my calculator. So I'm going to do 1,000 divided by parentheses 600 cosine 50 plus 550 cosine 38, close parentheses. I should get approximately 1.22 seconds, and I'm going to store that in the calculator, because what I need to do next is check what is happening at y of a at that 1.22 value. And because we've stored this, personally, I would store it as the letter t in your calculator. You can just manually type that in exactly as written. So you can just do 600 sine 50 close parentheses t, because we stored this value as t, and it will spit out a number for us. So let's see, I got 561.15, doing the same thing for the second plane. Do 550 sine 38 close parentheses t, which you have stored already, and you get 413.4. And remember, our units here are in miles. So these guys are nowhere near each other, so there is no danger of collision. And this is basically what air traffic controllers are doing every second of the day, except that they happen to have a third variable for the height of these planes as well. How many more are there? Goodness gracious me. Oh, the spider and the fly. Okay, so fly begins at point A, crawls at a constant speed along a straight line. 4 minutes later, it arrives at point B. So let's find the change in the x values. That's going to be 13 minus negative 3, so that's 16. Change in the y values is going to be, what is it, negative 17 minus 7, so that's negative 24. And it said that it took 4 full minutes, so delta t is going to equal 4. So from this, I can write the equations of the fly. So I'm going to have x equals 16 divided by 4 plus the starting value, which was not 13, but was negative 3. Negative 3. Negative 24 divided by 4 is negative 6t, and its starting value was positive 7. Okay, and we have t is just greater than or equal to 0. Ooh, the spider begins at point 13.5, crawls in a straight line, 8 units per minute at a bearing of 220. Ugh. Bearing of 220. Here's 180. 220 is going to be right there. Let's see, what would this be then? This was 40 past it. So this thing has a direction angle of 230 then. So that's really important for us. So I'm just going to basically do our vector formula, which is like magnitude cosine theta. That's my new rate. So it was 8 cosine 230 times t plus its starting value, which was 13. And let's see, y is going to be 8 sine 230 t plus its starting value, which was 5. So that is the spider's coordinates. So these are the two main ways we're going to have lines. One uses basically the vector component form going on here for the rate. So magnitude cosine theta, magnitude sine theta times t plus the initial start value. This one just uses delta x over delta t, delta y over delta t. And these are equivalent to each other. And we want to figure out whether or not this spider gets to eat tonight. So I'm going to start off by setting the x equations equal to each other. So 4t minus 3. And I want to note, when, at what time does this equal this t value here? So I just do a little bit of fancy math here. I'm going to add, subtract this to the other side, add the 3, and I'm going to factor out the t on this side all at the same time because I don't have enough room on my board. And that's going to equal 16. I'm just going to do 16 very carefully divided by all that junk, and I'm going to get approximately 1.75, which again I'm going to store because I need to plug that into each equation. So let's do the y value of the fly at 1.75, and let's do the y value of the spider at 1.75. And let's see, I got that the fly I think is negative 3.5 and the spider is negative 5.7. So that means no, the spider does not get to eat dinner tonight. Poor spider, lucky fly. No, markers going everywhere. Alright, again, I'm just going to use names that are on my answer key. So Trent can sprint at a rate of 18 feet per second. Mark can sprint at 25 feet per second. Since Mark is a bit faster, he gave Trent a 2-second head start. Ooh, so this gets a little bit trickier now. So what I'm going to do is model everything from Trent's perspective, okay? So when Trent starts to run, that's going to be t equals 0. We could do this whole equation from Mark's perspective, where Mark would be at t equals 0, but I'm going to, generally speaking, start it off doing it this way. So whichever person would start running first, that's when time would begin. So I'm going to assume that they're just running in a straight line, which I believe it told us, but I don't know. It didn't actually say it, but whatever. Let's just assume they're running in a straight line. So there you go, Trent. X equals 18t. Y is going to equal anything because we're just assuming that they're running in a straight line, just like that, okay? So they're not going at an angle where we would have both an x and a y value, just an x equation. Now, Mark's equation is where things get tricky. So Mark is running at 25, but he gave Trent a 2-second head start. So what we need to do is take that into account. So we need to say that Mark starts 2 seconds later. So let's think about this. When t equals 2, okay, so when t equals 2, then this will equal 0, and Mark's position will be at 0, the same position that Trent was at when t equaled 0 over here. So by basically building in this 2-second delay, we're allowing them to start at the same x value, but be modeling them with the same t value. And again, let that be anything. So there you go. Those are their equations. We want to figure out who's winning after 8 seconds. So we're just going to do x of 8, so 18 times 8. Everyone knows that. It's 144 feet, obviously. Do the same exact thing over here. So 8 times that, it's going to be 6 times 25 is 150. So Mark is already beating Trent by 6 feet after 8 seconds. I think this is the last one, which is super exciting because I'm tired of sitting on the ground. All right, using the same names as the answer key. Kayla. Okay, running 6 miles per hour. Okay, so I'm going to let them just be going in the horizontal direction. So same thing, y is going to equal anything. Let's see, Nika. What up, Nika? We got riding a bicycle. Ooh, okay, okay. Can go at 15 miles per hour and started 2 hours later. Whew. You guys are running and biking for way too long. That's not healthy. All right, so we got 15, and I need to make sure that when t equals 2, that Nika is starting at 0, okay? And at t equals 2, Kayla's already 12 miles in. Yeah, that's crazy. Don't do that. We're going to know when does Nika catch Kayla, so we're just going to set their x values equal to each other. 6t equals 15, t minus 2. So I think you can handle doing this math. I don't know, I guess. So let's see, this is going to be 30 equals 9t. So t is going to equal 30 over 9, which is 10 over 3, which is, let's see, what is that? That's like 2, and then 1/3 of an hour. So this is 2 hours and 20 minutes. Did I do that math wrong? Yeah. No, yeah, I did. That's bad. Whew, awkward. Let's try that again. It's not an approximation. It's an exact. It's a 3 and then 1/3, right? Because 9. Yeah, that was bad. So this is at 3 hours and 20 minutes. So it asked, when does Nika catch up? So remember, Nika started 2 hours later, so I need to subtract 2 hours from this. So I get 1 hour and 20 minutes later, she catches up. And we want to know how far away they are from Kayla's house now. So I'm just going to use Kayla's equation over here, x, and I'm going to use this value here for that. Okay, and when we do that, I get 20 miles. That's like way too long unless you're training for a marathon. So, like, well, crazy. And congratulations, I believe that is the entire practice. Woo! Yay, super awesome, amazing. I'm gonna stop the video now.